such that the nuclear energy will find its use for power production, which will eventually make India self-reliant. The same potential reasons of India's solar preparedness for the civilization of damage. Thus, it has such a fact that the European university, the equality must the law, and India is struggling hard. It must certainly make use of atomic energy at the highest level. In this context, we are privileged to have us on the Council for social agreements to investigating quantum damage. AICT is the first reference to the prestigious emotion that events are recognized to utilize these release of eminent possibilities by a way that exceptional advantages in the aspect of fields. One administration of one of the investigation of the AICT has organized a law for a distinguished chairperson, Dr. Anil. My request was that this is not associated with the country development of the effect to wait for the government and trees and yes.
Good afternoon to everybody. Very good afternoon to one and all. It's indeed a great privilege to Manipal Institute of Technology and MAHE to get eminent personality like Dr. Anil Kakodkar sir as distinguished chair professor through our AACT. It's a very noble effort from AACT side to share such a wonderful experience, knowledge, and wisdom of the eminent personalities who contributed to this nation to be available to all the students, faculty, and other dignitaries. So it's my privilege to extend a very, very warm welcome to Dr. Anil Kakodkar sir on behalf of MIT and MAHE and all of us. A very warm welcome to you, sir. May I request our beloved director to greet him with a bouquet. My hearty welcome to our beloved director, Dr. Anil Rana, sir. Welcome you, sir. We have with us the Director, Faculty Development Council of AACT, Dr. Amit Srivastava, and his entire team joining us online. A warm welcome to you, sir.
Thank you so much. Thank you. Thank you so much.
A warm welcome to our Joint Director, Dr. Somshekhar Bhatt. Welcome to our Registrar Evaluation, MAHE, Dr. Vinod V. Thomas. Very warm welcome to you, sir. My hearty welcome to all Associate Directors, HODs, faculty members, students, research scholars from MIT and all other neighboring institutions who have gathered here. Very warm welcome to you. And also very warm welcome to all the faculty, students who have joined us online. Thank you very much. May I request Dr. Amit Srivastava to say a few words as opening remarks before we begin the session. Over to you, sir.
Yeah. Thank you so much. Good afternoon to one and all. Respected Honorable Dr. Anil Kakodkar sir, Chancellor, Homi Bhabha National Institute, and Chairman Rajiv Gandhi Science and Technology Commission, former Chairman Atomic Energy Commission. So we welcome Dr. Anil Kakodkar sir in today's live program, where the students from the Manipal Academy, along with the nearby institutions and number of students across India, along with the faculty members and the head of institution, are part of today distinguished chair professor's lecture. We are also grateful to Colonel Commander Dr. Anil Rana, Director, Manipal Institute of Technology, Manipal, for giving the benefits of the distinguished chair professor scheme to the faculty members and the students, not only for his own institution, but the neighboring and the other institutions across India. So with this, I again, on behalf of the AICT, I again welcome Dr. Anil Kakodkar sir in the today live program of the distinguished chair professor scheme. So thank you so much. Thank you to the Manipal Academy also. Thank you.
My privilege once again to introduce Dr. Anil Kakodkar sir to this august audience in this afternoon. Dr. Anil Kakodkar, born in 1943, holds a bachelor's degree in mechanical engineering from Bombay University and MSc from the Nottingham University, UK. He joined the prestigious Baba Atomic Research Center, BAR, in 1964, and later he became the director of BAR in 1996. He served as a chairman, Atomic Energy Commission, and the secretary to the Government of India, Department of Atomic Energy, during the years 2000 to 2009. He was DAE Homi Baba Chair Professor during January 2010 to January 2015, and INAE Satish Dhawan Chair of Engineering Eminence during January 2015 to January 2017. And currently, he is AICT Distinguished Chair Professor. Dr. Anil Kakodkar has worked for the development of the atomic energy program in India throughout his professional life, with a focus on the self-reliant development of nuclear reactor systems to address the Indian program requirements. Dr. Anil Kakodkar continues to be actively involved in programs related to augmentation of thorium utilization in our nuclear power program and for development of non-fossil primary energy sources for meeting our overall energy needs. Dr. Anil Kakodkar has been a key contributor to India's strategic program. He was amongst the chosen few involved in the first successful peaceful nuclear explosion experiment in the India conducted on May 18, 1974 at Pokhran. And later, he played a key role in the series of successful nuclear tests conducted during May 1998, again at Pokhran, which probably I'm sure that most of us still remember. The comprehensive and robust program under Dr. Kakodkar's leadership has earned India a distinctive status as a country with advanced nuclear technology. Further, the deployment of technologies for improving the quality of life of our people has received considerable boost under Dr. Kakodkar's leadership. Some of the areas include energy, radiation processing of food and agro products, agriculture with emphasis on oil seeds and pulses, healthcare particularly related to cancer, urban and rural waste management, and desalination of water. Dr. Karkodkar extended his innovative contributions to human resource development activities as well, establishment of National Institute of Science Education and Research, DAE Mumbai University Center for Basic Sciences, and HBNI or Homi Bhabha National Institute are expected to result in a fresh wave of human resource development for acceleration of India's multifaceted atomic energy program. His other initiatives include new centers for research at Visakhapatnam, Hyderabad, Kolkata, and Bangalore. Dr. Kakodkar has over the years built competent teams of highly specialized scientists and engineers in the reactor engineering program. He has brought out more than 250 scientific papers and reports. He has chaired several committees, especially to give recommendations regarding education. Further, Technology Information Forecasting and Assessment Council (TIFAC) Apex Group, led by him, has brought out a technology vision 2035. A 60-page document was released by Honorable Prime Minister of India during the Science Congress on January 3, 2016. Dr. Anil Kakodkar was chairman, Solar Energy Corporation in its formative stage. He was also chairman of Inter-University Center for Astronomy and Astrophysics during 2006 and 2012. Chairman, Governing Board, Inter-University Accelerator Center, New Delhi, and Chairman, Board of Governors of Indian Institute of Technology, Bombay during 2006 to 2015. Dr. Kakodkar presently devotes his time primarily on issues related to energy, education, and social development. He has been propagating the concept of sillage, a knowledge-based ecosystem for bridging city and village gaps for technology-enabled sustainable development in rural areas. Dr. Kakodkar has been honored by all the 3 Padma Awards and the highest state awards from Maharashtra, Goa, and Madhya Pradesh, besides several national and international awards and honors. With this very brief introduction, I am extremely happy to present before you the Padma Bhushan awardee, Dr. Anil Kakodkar, and request him to kindly enlighten us on the topic relevance of nuclear energy in achieving net zero carbon dioxide emission. Over to you, sir.
Commander Dr. Anil Rana, Director, Manipal Institute of Technology, distinguished academic leaders, members of faculty, and dear students of this wonderful institution, colleagues from AICTE, as well as friends, particularly students who are joining this lecture online from different locations. I would like to extend my gratitude to AICTE for this program. I did deliver some lectures in the first cycle, and this is my first lecture in the second cycle. And I find this program quite useful. Engaging with students is always a joyful and meaningful activity. What I intend doing today is to kind of bring out a special situation that we need to address consequent to the need to reach net zero in terms of CO2 emission. And for India, this is even more challenging because our development challenge is yet far from being fulfilled. So we have to enhance our energy access, but at the same time, achieve zero emission. So, and it seems to me, and that is what I want to convey to all of you, that nuclear has been always important from a long-term energy sustainability perspective. But now, in addition to that, it has also become crucially important for India to achieve its development aspiration and at the same time do so adhering to the zero emission standards that is uh, that is so crucial for the stability of the Earth's climate and in that uh, uh, the very survival of humankind. And so that is the main theme that I'm going to talk about it today. Now, we're all talking about clean energy transition, meaning we move from fossil energy, which is the bulk energy supply today, to move to the sources that do not emit or emit very little carbon dioxide. And this is, there is a general awareness. We are all very clear about green energy, renewable energy. And I think that awareness is there across the country, across the globe. But I'm not too sure whether the, the challenge has been fully understood. And that's where I'm going to make this attempt to reach uh, that dimension to all of you. Now, what you have on this projection on the top right hand side is a correlation against Human Development Index on the y-axis and energy consumption. This is total energy consumption in terms of kilogram oil equivalent per person. And so first of all, you see dots in three categories, three colors. The blue triangles at the top, which are literally on a horizontal line, represent the countries where the quality of life is very high, very good. HDI nearly 1.95 or thereabouts. The red squares are countries where the average population enjoys average quality of life. And the light green diamonds are the countries where the quality of life of population is very low. And notice India belongs to that group even today. So the challenge is how can we raise our human development index and be a part of those blue triangle countries. And if you want to do that, we have to find energy resources. If you believe in this correlation. Now, this curve has, in the initial part, it's a sharply rising curve. Then it bends. And then asymptotically merges into a horizontal line. So that threshold, that knee, where this transition takes place, it's my proposition to all of you that India should reach an energy consumption at least up to that level so that we can get highest possible quality of life with minimum energy consumption. Now that there is a vertical line signifying that threshold, which talks about 2,400 kilogram oil equivalent per person. So we should take our energy to that level in the business as usual sense. Now that we have committed to reach net zero emission by 2070, and by the time India can be expected to surpass annual per capita energy consumption, that level necessary to be on par with the best of the world, as I said, the threshold per capita energy consumption, taking into account the improvement of efficiency as a result of clean energy transition. The point is, today we are getting most of our energy by coal, by oil, by gas, and the energy conversion involves various kinds of inefficiencies, most important of them being the standard thermodynamic efficiency, the Carnot efficiency. Now, renewable energy, which is where we want to go, or for that matter, even nuclear energy, there you first produce electricity. Now, that has its own efficiency. And so we're not talking about that efficiency. I'm talking about you start if production of energy as it is available and then use it for human good, human benefit. Now, using electrical energy for traction, or that matter even generating heat, starting from electricity, not starting from earlier stage. Or for that matter, many other aspects of energy use. For example, instead of running a internal combustion engine or running a car based on internal combustion engine, if you run an electric car, you do get much higher efficiency. Instead of running a train on coal or diesel and now electricity, you get improvement in efficiency. So while there is always an effort, for example, we have Bureau of Energy Efficiency, which has put in tremendous work to improve efficiency of energy systems. But when you transition from the current status of energy use to clean energy system, one would automatically gain certain amount of efficiency. And that gain in efficiency would be to our advantage. For example, you want to reach the high HDI, you require certain amount of energy. Now that you are talking about much more efficient use of energy, the total energy that you would require would come down. And the estimates are that this is significant. So whatever would be achieved by 2,400 kilogram oil equivalent per capita in the business as usual case, now it is possible to realize same level of human development index with just 1,400 kilogram oil equivalent. And that's the gain. But then if you use 1,400 kilogram oil equivalent per capita, multiply that with India's population in the steady state, then you would require a total energy requirement, and I have put that in electricity use term, but this is total energy. So you require a total energy requirement of 28,000 terawatt hours per year in India. So remember this number. This is extremely important. 28,000 terawatt hours per year. Currently, if you take all electricity, oil, coal, everything put together, we are at around 6,580 terawatt hour per year. So we have to see a jump somewhat higher than 4 times. And that is clearly achievable in the available time with a modest CAGR of around 4.78%. So this is doable. This is the challenge that we now want to find access to 28,000 terawatt hour per year of clean energy, energy which does not emit carbon dioxide. Now, of course, obviously, the first thing that strikes us is renewable energy. And we have a notion that renewable energy is vast. It is. These numbers which I am telling you, they are really vast. They are far, far higher than what we are normally used to. But then, after all, we can collect energy essentially on whatever energy we can collect on Indian landmass, maybe a little bit of offshore. So there is a nice paper by Professor Sukhatme in Current Science, and he did this work way back in 2012. And it's a very detailed study of how much renewable energy we can access. And that paper says that the total assessed renewable energy potential in India is around 5,855 terawatt hours per year. Compare this with 28,000. So one thing is clear, that you are not going to meet all our requirements. Assume there could be error because, these estimates are full of errors. So you can assume 20, 30, 40% error. That's not the point of debate. But this gap is too large to be bridged just by renewable. So I started searching some more things as to. Now, at that time when these estimates were made, biomass was assessed to be only 60 terawatt hours per year. Now, biomass, good part is actually non-commercial energy. Rural kitchens, they run on cow dung cake or firewood. But in terms of total energy consumption, that's a significant fraction. Maybe around 20% of the total energy that we consume in the country. And that is because it's not commercial energy. When you talk about the commercial energy statistics, this is not reflected. And of course, the data availability is also a challenge. So I did look at whatever literature one can lay hands, and I find, again, there could be a lot of error there. But I find that the potential bioenergy that we are likely to have is around 2,500 terawatt hours per year. So add 2,500 to 5,800. So you get something like little upwards of 8,000 terawatt hour. But still we have that deficit. And the only other non-emitting source does not lead to CO2 emission is nuclear. And nuclear can provide that kind of energy. So this is the first point that how to reach there, how to get that is part I'll come to. But this is the fundamental point that we must recognize. So, this diagram here in the picture is very faint, but it's a diagram called Sankey diagram, which essentially talks about energy forms available at the supply end. And then you go through several transformations and provide energy at the demand end. For example, you use coal, you convert to electricity and supply. You get crude from outside, put it in refineries, convert it to gasoline, diesel, LPG, and supply. So these transitions, they take place, and it's not as if there is one-to-one correlation. Our industry runs on electricity, industry runs on oil. Our agricultural, or for that matter, our households run on electricity, but we also require, call it LPG or call it the compressed natural gas or some such heat source, or as I was saying earlier, in rural areas, cow dung, firewood. So you use different energy forms for different uses in different sectors. So this is a complex connection between the supply side and demand side, and a quantitative connection, which is given in a report published by Government of India every year. And so this is, I just picked up. And because that diagram is so complicated, so I picked up some numbers and put them in tabular form on the supply side, which is there on the left-hand side, and on the demand side, which is there on the right-hand side. Now, even that is, I think you may not be able to read those numbers, they're very small. By the way, these slides, I have no difficulty if you freely distribute to people, absolutely no issue. But the broad characteristics of this transition, particularly the transition to clean energy, is number one, today, the clean energy plays something like just around 3.7, 3.9% of total energy. I'm not talking about electricity, I'm talking about total energy. So there has to be a very rapid scale up of utilization of clean energy resources. Now, while this is happening, most of these clean energy sources are variable in nature. And as I told you, most of them primarily generate electricity. And while you can have stand-alone solutions for these electricity, like rooftop solar or things like that, but a good part, I would say most of it has to be managed through electricity grid. And electricity grid has to be under dynamic equilibrium, but a very stable dynamic equilibrium of supply and demand. Otherwise, we know grid collapses. Now, this situation happens even when you have steady sources, but largely varying loads, daily load curve and things like that. When you have that the source and the generation and also varying sources, then the problem becomes still more complicated. And so, and there are many issues, I'll talk about that in a moment. But it's important that you must have a source which will compensate for this variability. If the supply side generation falls because of some cloud cover or some weather related issue, you must pick up some other generation at a great speed. And on the other hand, if there is enough supply available, you must back down. Today, we are backing down using coal plants, which is actually a challenge. But you can do so very easily with gas. So, gas is often described as the bridging fuel. And so, there is, yeah, as it is globally, if you see, gas occupies something like 16 to 20% of the energy basket. Whereas in India, it is just at around 6%. So, when we go to net zero, obviously there cannot be any gas. But within this 30, 40, 50 years, gas must play a very important role. Otherwise, our life will become very difficult. You cannot manage these transitions with coal. On the demand side, a major transition, today we are used to primarily oil, solid fuel, and electricity. It will change to hydrogen, electricity, and bioenergy. That will be the complexion on demand side. The proportion in different sectors might be different. For example, residential and agriculture segment, which uses something like 32% of the total energy use, would be predominantly electricity and bioenergy. Industrial, which is a very large segment, nearly 55% of total energy use, it would have to be a mix of electricity, hydrogen, but I suspect will not be able to meet the total requirements. So we will have to continue using hydrocarbons and coal, even when we reach net zero. But then what to do with the emissions that will arise? And so you have to bring in these technologies for carbon capture, utilization, and sequestration, which is we're just in infancy, we're not even seeing. And to do that in a cost economic fashion is a challenge. But that, at least, if you can make that part zero, ideal. But I don't think that will happen. And to that extent, we have to organize that. And transport, which is today essentially on hydrocarbon, I think it will become primarily on electricity and hydrogen. Now, this is the table which I mentioned. How much bioenergy do we have? And I don't want to go into this, but it looks at firewood, it looks at animal dung, surplus agricultural residue, municipal solid waste. And if you sum all that, it comes to around 2,500. And I think that is something which we must put to good use. Not the way it is being used, which leads to a lot of smoke, lot of health issues. You need technology to make use of this fuel, for example, compressed biogas. And then why can't our kitchens, both urban as well as rural, run on compressed biogas the way they run on LPG, and set up plants, decentralized plants in various predominantly rural areas, and have cylinders filled with CBG and supply. And this technology is available. I don't know why we have not done it so far. It has been done, but not on the scale that is required. So much of energy we are not really leveraging, but I think there is energy there. So what are the potential mega trends? I'm not going into detail, but the broad trends that you expect. While total energy consumption would increase 4 to 5 times, as I told you earlier, and that will be at a rate consistent with the economic growth. Because, you have to pay, you have to invest, and that capability will be there only if economic grows. So the demand for energy and economic growth, they are closely related. But then, while this will happen and go up to 4 to 5 times, the clean energy consumption would need to go to something like 80 times from where we are today, because you have to replace the fossil energy. And that has to be at a rate consistent with the, whatever mandate we have set for ourselves for reaching net zero target. And this increase has to come primarily from renewables, including bioenergy and nuclear, as I said earlier. Now, except biomass, all other clean energy resources, they first produce electricity, whether it is solar, wind, nuclear, they all produce electricity first. Now, there are also possibilities of producing heat, high temperature heat that too, using solar, for example, concentrated solar. There are also possibilities of producing high temperature heat using nuclear, for example, high temperature reactors. And these have become important because hydrogen will play a very important role. And there are two ways of producing hydrogen broadly. One, that you produce electricity first and then electrolyze water. And that is what everybody is talking about. Now, if you do that, then you lose efficiency in producing electricity and then converting that electricity to hydrogen. On the other hand, if you do thermochemical splitting of water using this high temperature heat, then you produce hydrogen in one step. That also has its own efficiency. But because it is in one step, the total efficiency, there is a much more gain. And clean hydrogen, the cost of clean hydrogen is a challenge today. So I think it is important that we develop these technologies for direct splitting of water using high temperature heat coming from solar or nuclear. And but that's an important thing, but failing which you must recognize that except bioenergy, it is first electricity and then everything else. And that is the way that transition will take place. Now, what will be the share of electricity in the total energy mix? That is dependent on what I just said. So, share of electricity would, of course, today it is around 80%, 18%. That obviously will go up to at least 35% if bulk of the hydrogen we are successful in producing it directly without going through electricity. But supposing, that technology is a little behind electrolysis. Electrolysis is today industry's first choice is electrolysis. And supposing we are not successful in developing this direct production of hydrogen, then the share of electricity in total energy consumption could well go up to 80%. Today it is 18%, it could become 80%. And the remaining, of course, would be biomass and little bit of fossil energy, as I said. So, and there is a huge amount of economics related to this, which we need to be conscious about. So we need an optimum mix of electricity generating systems to assure diversity of supply, optimum peak capacity, which I mentioned, because we are talking about variable generation, and the investments necessary for that peak capacity. And of course, in all this, we have to be also concerned about stability of the grid system. So that's the major change. So our grids will become, as I told you, maybe 80 times larger, because electricity today is only 18%, which supposing it has to go to 80%. So there is a factor of 4 there. And then we have to enhance the share of clean energy from around 3.9% to 100%. And most of it will be again electricity. So there is this huge jump in the electricity system that we are talking about. So let us also worry about or look at the cost. We all have a feeling that renewable energy is very cheap. It is. But it is cheap at the generation end. As it is produced, it is cheap. Solar, wind, they are cheap. If I have a local decentralized supply rooftop, I certainly get very cheap solar energy. But when you talk about operating a grid, then you have to also invest in the peak capacity, taking both the supply side variability and demand side variability. And that investment could be quite large. And the producer, he says, I have generated and given to the grid. But as far as we, the buyers, are concerned, we have to pay. The distribution companies, they have to buy this. They have to invest in batteries. They have to invest in other peak capacity, as I said. And all that they will recover from the consumers. So what you see in this picture, that kind of a hill that is appearing, that is on a 3-axis diagram where vertical axis is the cost of electricity. And the 2 horizontal axes, one is the carbon emission and the other is the mix between nuclear and renewable. So if you go close to the origin of this diagram, which is into the page, then you would find that the cost of electricity actually peaks up. But if you approach zero emission, bypassing that peak, because there is a plateau if you come to the left-hand side. So you approach zero emission, bypassing that peak, then you can keep your cost quite low. And that bypassing means the share of nuclear has to go up. And that is the value of managing a proper mix in the grid. These studies, unfortunately, in India, we don't have these studies. Only recently at IIT Bombay, a study has been got done. It is yet to be published. IIM Ahmedabad is also doing such a study. But studies done abroad, including, in fact, this figure is from an OECD report. So they are very conscious about it. Sometimes it occurs to me that we are blissfully ignorant about these issues. So taking all that into account, what should be the key elements of sustainable clean energy policy? Simply stated, it's obvious that electricity, hydrogen, and bioenergy, they will be the key feeders for meeting the demand, as we saw earlier. I think we should reserve compressed biogas arising out of the available biomass and also bio-CNG. That is, you process it to make sure that the methane percentage is at the highest. We should reserve that for running the agriculture machinery, running our kitchens, both in urban and rural areas. And because of course they can be used for transportation also. You can, if you can run your vehicles on CNG or other thing, you can run it on CBG also. But there are alternatives available, for example, hydrogen and electricity for transportation. Whereas I can't imagine bringing hydrogen in our kitchens for cooking. Maybe several decades down the line, the technology will become safe enough, and that might also happen. But I would not recommend that happening anytime soon. And so we should reserve compressed biogas for our kitchens, and also where, this large energy would be in the hand of people who may not be all that techno savvy. So this is the second important element of our policy. We must emphasize decentralized renewable for rural and remote areas through microgrids interconnected with main grid. And as I told you, decentralized renewable energy makes a lot of sense. There is actually economy there. Of course, it cannot contribute very much. The total energy will have to come through centralized. But wherever possible, we should deploy this. Now come the big ticket items. Develop and deploy solar, thermal, and high temperature nuclear reactors for hydrogen production through thermochemical splitting of water. Now, in terms of total energy, remember that 28,000 terawatt hours which I mentioned. Out of that, we should derive 2,500 terawatt hours through bioenergy, the CBG, which I mentioned. And this part, hydrogen, because all industrial energy requirements may have to become there. That number could be a staggering 15,000 terawatt hours. And that's today thermochemical splitting of water is only in the laboratory all over the world. So you can imagine the challenge before us and the world. Coming to electricity, we must augment electricity generation based on optimum mix of renewables, hydro and nuclear. And that would account to, in my assessment, something like 10,000 terawatt hours. Presently, we are around 1,600, our electricity system. But it could be even more to bridge the shortfall in hydrogen production if we are not able to leverage high temperature process. So it could become 10,000 terawatt hours, or it could become 25,000 terawatt hours. And finally, as I said earlier, the balance we may have to do using, it may be small, but we may have to do using fossil fuel, back it up with CCUS. Now, all these transitions mean a lot of money, and I don't want to spend too much of time on this slide. But just to tell you that we are today producing something like 1,600 billion units, not terawatt. It's the same thing it comes to. Now, and then of course, we have to grow to, as I told you, either 10,000 or 25,000. Now, transition in US, where the electricity system is around 4,000 terawatt hours, it has been estimated to cost something like 4.5 trillion US dollars. In Germany, which is just 650 terawatt hours, it has been estimated to around 580 billion US dollars. So compared to that, look at either 10,000 or 25,000 system and just think how much money you would require. And recognize that today our GDP is around 2.8, 2.9 trillion dollars. We're talking about $5 trillion economy. So we can't be spending everything in this electricity itself. There are many other things to do. So this is a huge, big challenge. As I mentioned, nuclear can provide a solution to at least bridge that gap in terms of energy. So it will also cost money, but it can at least make the energy available. We have in India, as many of you would know, developed domestic technology, which runs at global class performance. We got world awards. Even the Kaiga power plant, which is not far from here, had made a world record of continuous uninterrupted run. These units are available at half the specific capital cost compared to units made abroad. So I think the key for us is to multiply them. And today, of course, government has given sanction for 10 units to be constructed in fleet mode. There are 5 more units they were already under construction. But I think we need to take up more such fleets. We should also expedite a program of light water reactor construction, which is supposed to come through international cooperation, which looks like is on a slow burner. We must also, as we emphasize our PHWR capacity buildup, we must also get into export market, because we have to worry about the viability of the industry. And industry, if you have as diverse a market to cater to, it's so much better for de-risking the industry operations. And of course, it's a huge contribution to manufacturing sector, which is actually the key to growth of Indian economy. Whatever we are talking about in automobile, defense, we can also add this, and it will boost our economy. And finally, we should also talk about the small modular reactors, which is in the, there is a global movement towards that. And what's going to happen is we are going to have a large number of thermal power plants, which would be retiring. Some of them because their age is getting over, but by 2070, all of them will retire. So these sites are available. So there is cooling water there. There is a grid connectivity available there. There is a railhead from which you can take the components. Now, they can't take these big power plants, 700 megawatt, but you can certainly take the smaller units. So we should build that product and some work is going on in that. So it's a combination of all this, even within nuclear, that will add up to meet our target. And that's a big challenge because that number is very large. Now you may be wondering that this fellow is talking about THWR, light water reactor, and what about India's three-stage program? What about thorium? Now, three-stage program and our ultimate objective of making use of thorium in large quantities, I think that objective is as important and as crucial as it was when Dr. Bhabha talked about three-stage program. But the problem is, this involves several technologies. We have completed the technology development for the first stage, consisting of uranium reactors. We are in the second stage, and it's taking time, as all of you know. We also did a lot of work in the third stage. But you have to develop these reactors, you have to develop the fuel cycle technologies, and so it's going to take time. But it is important because 2070, we will reach net zero. But that doesn't mean that our energy requirements will come to an end at that point of time. We will require energy almost in perpetuity. And that is where thorium becomes important because we don't have so much of uranium. So this program is important. We should make progress as fast, as quickly as we can. But today the challenge is to do something even faster in the context of thermal reactors. And while we develop nuclear reactors, we have to also take care of many other critical energy conversion technologies. For example, steam electrolysis, the solid oxide fuel cell cells, or SOEC as they are called. Or as I mentioned, the thermochemical splitting of water. Storage is going to be a big challenge, whether in terms of battery or in terms of thermal. We require production of hydrocarbon substitutes using hydrogen and biomass. It will reverse now. Earlier, we used to use hydrocarbons to do everything else. Now, hydrocarbons and more particularly petrochemicals. Petrochemicals is something which will require in large quantity. So we need to produce petrochemicals. And if you produce petrochemicals using fossil fuel in a manner that does not emit carbon dioxide or greenhouse gases, that is priority number one, eminently possible. But we could also develop many of these value chemicals, leveraging biomass and hydrogen. And then, of course, CCUS is a whole host of technology that we need to worry about. Now, this is the status of carbon capture and utilization in India. Some things have happened, but we need to recognize that CO2 emission is 2 to 3 orders of magnitude higher than current carbon dioxide use, all kinds of uses put together. So this is not a small problem. And so we need to make a lot of progress on this. Now, this is where, the way we do things would become important. We talk about almost everything on earth, but when it comes to delivery on large scale, we always end up importing, which means it costs money. We have to pay through our nose. And I told you the kind of money that is involved. So I think our R&D system, science and technology system, its translation to industrial commercial use has to pick up. That track record has not been very, very encouraging. And that is important. So I think we should develop, first of all, priority number one, we should develop sufficient insights in terms of what we want to do rather than being driven by vendors. Today, what are the pathways that we want to follow are actually dictated by vendors. You can think about this. I'm making a bold statement, but it is true. Because we don't have confidence on ourselves that I can do. So the best is to go to the market, buy. Now, if you have infinite money, you can do that. But remember, India is a poor country. So the ability to connect basic research, applications, proof of concept, technology, commercial deployment, and we bring all these diverse groups together with groups with complementary capability and put them in an ecosystem where they work synergistically together. Very important. We are talking about there's a lot of thrust to innovation, a lot of thrust to startups. But by and large, they are individual efforts. By and large, they are small group efforts, which is important, good beginning. But we have miles to go on that. And so all this to be done, whether everything will be driven from top or whether everything will be done from bottom. I think we need a combination, a healthy combination of top down, because the broad picture has to be identified on a more deeper, more comprehensive study. But you can't be working out micro details at that level. Consistent with that broad picture, people at the grassroots have to carry out their individual detailed work to fill in the blanks. And that kind of synergy we need to bring in. So I come to the end of my presentation. To sum up, India can become energy independent. Recognize this point. Whether it is solar or whether it is nuclear, particularly based on thorium, all that energy is available within the country. So today, good part of our energy, particularly hydrocarbons or even coal to a large extent, gets imported. And energy bill is the largest foreign exchange outgo for us. If we make this transition, which we have to compulsion, you will find all that happening within the country. And so while we are talking about net zero or clean energy transition, we are concurrently achieving energy independence. Large share of nuclear energy is necessary both for sufficiency of energy supply as well as economic viability. Otherwise, the energy system will not be viable. Share of electricity in the overall energy system would go up substantially depending on the mode of green hydrogen production, whether it is electrolysis or direct splitting. Bioenergy should preferably be leveraged for cooking energy as well as for agricultural machinery. And new technologies, I listed some of them. New technologies would be needed both at the supply end as well as at the demand. So with that, I thank you. Thank you very much. Follow me. Ah, okay. Good.
We need some. I'm sure you can go on sitting at the camera in the industry. For any company to one of the security. India is next to one of the world's largest uranium reserves. How many years away is India working towards data reactor so that we can stop the working uranium reactors and end development program with the program? My second question.
How many things? You are saying how many years away we are from working here? Yeah? Okay. Go on.
Over the decades, we have seen that whenever there have been elections and community establishments, the people in the sector reaching the waters of the next state. Do you think safety concerns people side up? But are they part of the larger questions of the city in India and Australia? Third question. Recently, there have been news articles stating that the French president will be visiting India in early 2023 to announce the setting up of 6 ongoing industrial reactors in Maharashtra. Recently, there have been news articles stating that the French president will be visiting India in early 2023 to set up 6 ongoing industrial reactors in Maharashtra. Is this really true?
The first about the past pandemic. Now, this is true. Why past pandemic? Even PHW or development has taken a long time. If missions were not said, I would have wanted this to happen at least 3 years earlier. So, but that didn't happen. And there are many reasons. Reasons were first that I mentioned in terms of RNG transmission. Here, India and we are not the best system. But there are also reasons about the restrictions. So, India has conducted itself on one side technology development, on the other side guarding the or preparing for the security of the country. On the third side, by doing so, India has maintained a responsible position. The whole world, India is the only country which is recognized to be, to do that development which the world doesn't like. But they all agree that this one is responsible. So, but the fact is, it has taken time. Now, past reactor ability, the same. The time we went to thermal reactor development, which was primarily ideas. And similarly, we are going to the past reactor development, which is being done primarily. Now, I've done that. In the problems, they're constructing a 500 megawatt electricity hospital reactor, which should have been commissioned long time. Absolutely. But these are technologies. And even today, my colleagues are asking deep questions. Because you can't, these are first of time techniques. How many countries are there which are operating fast? So it's crucially important for us. We have to develop. Also, I feel we have to develop fast, but we can't make mistakes. German will happen to Fukushima. India has not made a mistake. That's something. Um, painted picture in front of challenge in front of us in the context where you feel helping. If all is for availability, but because no way will be available unless we do take on our own. And there are, you won't find many other examples. Space, defense, agriculture. That's it. So I think you should be proud of our work, not go by what's again. Those things are true. Those are crucially important. But I think we should look for solutions to find out how we can accelerate rather than take a position of a critic, you don't do that. It's very easy. I can recommend you journalists, it's very easy. See, I'm talking I was delivering a convocation matrix with managers. And I told them that look, activism you can speak. There is nothing wrong in being active. But the activism to the point of the problem, I say, a solution is not my responsibility. Young generation should not do it. I think we must. If you want to consider activism, that activism in terms of finding solutions, that is what we think is the people. Otherwise, activism allowed in the world needs travels very fast. Something has happened in any part of the world. Within a couple of hours, we have things all over. And if you just get into this activist mindset, graduates of management school, that for heaven's sake, you give education to be an expert and not an activist. So that is the first question. What was the second question? You got it? Used to mind.
Over the decades, we have seen that many of the last three plans to set up various challenges. The people of
Now, this is another thing. I think people protest for multiple things. And activists have played a lot of role in that. So that part I will not want to, but that is a very significant part of this issue. But at the same time, any big project, and you should not restrict it. Any big hydro project, any big industrial project, where there is land acquisition, where there is large scale investment. The fact is that this affects both ways. It creates opportunities, it also creates challenges. And the project proponents have to see that the difficulty, the challenges are limited and the opportunity. Now, and it's, you have around the last project, and you see like something like typically 10-15 kilometers surrounding that project area. Some people get affected, but I think also some people get affected because I just want to be an agriculturalist. Because I have, that's my value. Mother Earth. So I don't. That's an important thing that should be respected. There is another element to this. And that is, well, now the government has increased land compensation to very attractive units. But my neighbors finally getting acquired, my land is not beginning. So I lose that. Now, it doesn't make good sense to talk in public that trees acquire. Government says no. Yes. So what do I do? I need not come to this is the government. That is it. So I run that. Okay. So it's how it is. And I can go on. So the short. And this is not restricted to me. 18 when the dark and it's significant land activity. So it's a sensitive issue. It's a general issue. We must understand and address the points. And at least I have people over a period of time, they understand when they speak to the benefits. They is some kind of like some of the other people. Everyone will be kind of I know this to be something. I think today people have seen the benefit of it. I got something that has been next to it because of the all lights. They really either the same and you make it 3 minutes. So one thing is there is this what they call NIMBY syndrome, not because it could be also for relation, fear of relation. But this is all very good. So this has to be understood, explained. It's a matter. That's and the third question was
Second on since you are the question of the areas of Maharashtra.
the question is there are for that project the language everybody has taken the compensation. There was application there also, but everybody has taken. Right. So that is no longer a constraint. The constraint is what will be the price of the electricity to the students. And obviously, if the price is not economically competitive, then it will not do. So they are doing what we negotiating. Like today, again I come back to making here. Indian highway, where other economic space, Mana, Mangalia, or several aspects of the database. Indian highway, you make it in India, you would make it much cheaper, maybe even half price. Look at what it is, and what cost. So this mindset that we, as I said, can get it in. First of all, they have each other problem, but you have to figure out and people live. And that is also very calculated in case. But they said, man, instead of seeing some of the things, differential valuation. And that's what Pradhan is doing. Next one.
Good evening, sir. My name is Vishwanath, Department of Analysis Solar. Sir, India is fourth largest consumer of energy, fifth largest economy in the world, and second largest populous country in the world also. And we are responsible industry. Everyone has to know. Despite being all of this, we are constantly being denied entry into Indian supply groups, thereby putting off critical nuclear technology. Sir, as an Indian, as a proud Indian, how can I imagine my country's ambitious nuclear program, both civilly as well as military?
Well, see, these don't happen by dating. These things happen by exerting your hard and soft power. In international politics, there is nothing better. All this we talk about, we should talk about philosophy, we should actually take the world towards good behavior, good values. These are all very important. But the hard reality is the international politics or geopolitics is driven by the interest of countries. This is love. So we need membership of nuclear suppliers to, so nobody is going to come and give us. Oh, India is a very good country. I know what's happening when we negotiate civil nuclear deal and reserve people are interested in killing your country. So this is point number one. Now, at this moment, with the current situation the way it is, while the membership of nuclear suppliers group is important, and we must work towards. But I don't see the risk in the program, and we can take anything, and again take anything which nobody is going to give you the so-called D-tech. Everybody will give you technology, which is sort of in second rate or third rate. So, but if you develop a technology yourself, then it will make a big line and say, no, we are going to give you even better technology because we don't want to lose market. So, you know, one of my friends living in embargo, he was in the electronics and controls, and he used to get great difficulty in getting components. Making all these things are there. But you need components. And those critical components, they will be always denied. So we used to adopt a simple practice. Moment that we implement a project, it will make a bill of materials and raise the intent. So some people will come and say, yeah, we can supply. If you can supply. If you cannot supply, don't supply. It's fine. But he has to actually implement that project on components which are acquired from his stock. Correct? So we have to say he doesn't seem to be concerned about whether we'll put embargo or not. So let us do business. So he used to build stockpile and very carefully managed. Now what I told you in technology, similarly can happen in many other areas. Hopefully, including areas. But It will not happen by getting into a debate or getting. You must create conditions where world feels that they are missing out. Then everything must be. That's my view. I'm not too sure that everything will be, but that's it.
Don't you think NFC, nuclear supply would contribute more? Don't you think so?
You already like. Let me tell you this, it is recorded in this US. What it says is that we put embargo on India. Putting those embargo on India, what we did is delayed their electricity generating from nuclear electricity. Power program was delayed, which is what we talked earlier. Then he said, let us ask ourselves whether that was in our interest or it was against our interest. Because they must see geopolitical importance of India. And so India becoming, economically a strong player was in their important interest. On the other hand, we put embargoes because we didn't want India to become strong on the strategic nuclear weapons. And there we have not been able to stop. So he recommended that we must cooperate with India. And when we cooperate, we can also put our lines here that this we don't do. So nobody is going to give us critical technologies which we don't. They will give you technologies which we have. And as my friend used to say, you can decide whether you want to buy it. So I don't look at that as, after 74, Sion that they climbed and they created energy. And this is all the, as I said, all countries act in their interest. That is the bottom line. There is a hand raised here, after that you can. Yeah, please.
So my issue is from macro actually. After nuclear power and disasters, central European countries are facing a lot of nuclear problems. What are your views on it?
And again, there is a harm, I'm not able to. Which disaster you are talking about?
The recent companies are nuclear power and so after that, central European countries, Belgium,
Can you explain? I'm not.
After few nuclear reactor disasters, some of the countries are going away from nuclear power. This is recent Japanese disaster.
Okay, all right. See, it is very interesting. After Chernobyl, if you look at the graphs, you will find that the deployment of nuclear power sort of decelerated. But then, after some years, or for that matter, a few years before Fukushima, if you look at the same graph, you are seeing that the nuclear power capacity addition was actually accelerating. Then Fukushima happened. Again, it came down. Now let's look at how different countries looked at this. Take case of Germany. Germany, even before Fukushima, had their phase out policy. This is they wanted to phase out. And the reason is because German government has always been a coalition government. regardless of which major political party came in power, there was always this Green Party, which is the coalition government. And one of the condition was that nuclear is something which they didn't like, so that was on a back burner. So when Fukushima happened, they accelerated that, and by this time they should have shut down all the units. And now with the Russian gas pipeline and the energy issue in Germany, you must have heard that in Germany, that phase out of nuclear power plant has been shifted to next year. It was to happen this year. It will happen next year. So if something is unsafe and you get it timetable, you should shut it down. So it's always cost benefit. I perceive a risk, I perceive a benefit. And everything in life is like this. Look at Japan. Fukushima happened in Japan. And the whole sensitivity about nuclear happened because Japan suffered nuclear bombing. Hiroshima, Nagasaki. Japan actually shut down its nuclear power plant, but not permanently. They shut them down for review, safety review. And after carrying out safety review on a step-by-step mode, a number of units in Japan have been brought back to operation. Again, I said, the media, that doesn't come. That Japan has started this unit, it never comes. Even more than that, the official Japan, there is huge sensitivity. There are a lot of people who are opposing nuclear power. But the collective view of the country, as approved in the Japanese parliament, says that nuclear will remain an integral part of the energy mix in Japan. Even their long-term energy policy shows nuclear to be 20%. So this is Japan. Now, and they are much closer to the accident. And they have seen the impact. 2 days back, we must have heard a news from Sweden. Just like Germany had declared phase-out policy, in Sweden they had declared a phase-out policy. And they have been differing. But the new government, incoming government in Sweden, has actually announced that we should now, in fact, think about not only reversing the phase-out, but also creating a large new grid of nuclear. And Sweden is all for nuclear, rich resources of, all for renewable, rich resources of renewable energy. But they have, the incoming government has just, so after I think 3 decades in America, the new reactor, the fuel is being loaded, will come online. So this risk benefit is you have to balance. There is nothing like zero risk. And there is nothing like a disaster. People say Fukushima was a disaster. But they don't say along with that a disaster happened because of tsunami. Not so much, but everybody finds Fukushima happened because of that reactor. The reactor got damaged because of tsunami. Thousands of casualties took place because of tsunami. Nobody died because of radiation exposure. Or for that matter, nobody suffered grievous injury because of radiation in. So, in fact, I have written a couple of papers on, in fact, title of one paper was Nuclear Safety and Disaster Syndrome. the way we perceive a disaster and the real safety, they are not same thing. And to give you an example, today it has not changed, but if I ask you a question, whether air travel is safe or car travel is safe, what did you answer? Any answer? You visit Google and ask a question. Fatalities per kilometer, per passenger kilometer travel. And you will find that car travel is most hazardous. Then railway travel. Then air. But you travel by car at a time, the number of passengers are 3, 4, 5. So fatalities cannot be more than that. So the notion of disaster is a car travel is not as now as the aircraft accident where if a jumbo jet crashes, maybe 400, 500 people will die. So that's the disaster. So you think, and in fact, I know my childhood, if I go to Saranaghat airport and check in, the next activity after check-in was to go to a counter, opposite check-in counter, which was air insurance. Fully knowing that all passengers are insured, people used to take additional insurance right at the airport. And it was a big business. Today, those insurance counters have vanished. So, these two things are not exactly identical. And the government have to depend on vote bank. So, they do a very fine balancing act. German government does it because they have been party in their coalition. So, they do it in one way, secret phase out, then there is now Russian gas pipeline problem is there, so delay is second. Japanese government is bold. They say, okay, all that happened. But Germany, if they run short of electricity, they will just telephone, their grids are connected from the neighboring country, power will flow in. In Japan, it cannot happen. So, energy security connotations are different for different countries. So, just because somebody says, and this is where I come back to my point on that activism. This activism is damaging the mindset of young people, terribly. And that only young people can solve it. So that's why I say what is. Thank you.
We have one last question. One last question, please.
Hello, sir. My name is Jay Ross, and my name was from the Department of Renewables. And I have a question regarding viability international thermonuclear. I just want to know what are the India's contributions in this organization.
What are the India's contribution?
And what can India learn from this? Their implementation by the Navy for.
Yeah. In fact, the lead larger had a question asked me the AI. And you know why is this taking place? Fusion technology is an example of human life. For example, many people, I wish they never said that kind of thing. It has become a common joke. And that joke is that fusion technology at any point of time is 20 years away. And now, if you really face the history, you can't blame them that they have that thing. But the fact is that either the number of countries, there are 9 parties participated. There are only those parties who are technologically capable of contributing. Because it's not just cash, it is cash in kind. People have actually made equipment and supply. But if you calculate the total population that they represent, these 9 partners, that actually is much larger than the 50% population of the world. So it's a global effort in true sense. Now, ITER is an experimental facility to demonstrate net energy release at 500 megawatt scale. Now, ITER is not going to produce electricity. It will show that you can run a fusion system and get energy released in a sustained manner. Now, this has been done by, Indian countries have their own programs. There is a program in the United States, there is a program in UK, other countries of Europe, there is a program in Russia, a program in Japan. Recently, there was a program in China, Korea, even in India, Institute of Plasma Research has been in the domain of research. Now, so this program is to demonstrate ideal manipulation together their efforts to demonstrate the net energy release. Once that is done, there will be need to build another project. Let's call it demo. And that demo would be to build a facility where not only have net energy release, but convert it into electricity. That will be the second step. And once you do that, then we can say that now we can scale up this technology usually. And there are challenges there as well. So with that background, let me come to it. So what has India supplied? India has supplied the world's largest cryostat, which was made in Latin Tobruk. Of course, it's a huge, big structure. Its diameter is larger than the width of the Sol. And of course, the length is much larger. So diameter is a little bit same. So it has been built in several panels. And then these panels have been shipped. They were assembled at Relevance in 3 layers. Then they have been installed in place, and again, they will be classified. Similarly, India has supplied several, they call it plumbing lines, but it's not as simple as the plumbing lines that we have in the bathroom. There are plumbing lines for carrying liquid helium. There are plumbing lines for carrying nitrogen, liquid nitrogen. They are massive. So a lot of them, they are all been made in Indian industries. They have supplied a lot of power, high power electrons. And I think the total cost of India supplies, I don't have the latest number than in the system now. But it will easily run several thousand crores. All in industry. So it's not just laboratory work. But in spite of that, the future challenge remains. And you must be reading in the newspaper. There are people who are talking about alternate modes of fusion energy release. And all these efforts will go on. So let us see, but it's very crucial. Just like thorium is important for India, fusion energy is the ultimate. Because we have to secure energy for the mankind. If humanity has to survive on Earth, let us say several hundred years from now, then the energy resources we are talking about, either they will be exhausted or carbon dioxide emitting sources, they are not usable, or they would be nice because energy requirements keep growing up. So this is absolutely important for the long-term energy security of the world. So that's probably the answer.
Very good, sir. Thank you for your presentation. Sir, from Neeraj Chedda, the Indian Master Student at the Department of Geopolitics. Sir, I have celebrated the resources of beginning to discuss. In the current government is making administration of ethanol projects like so in order to reduce the carbon emission. So do you see it making any starting impact in the coming years?
Yes, it has a lot of impact. For example, see, ideally, ethanol derived from biomass, if you use, obviously, that leads to carbon dioxide emission, but it's not a net extra emission. The biomass, it absorbs carbon dioxide, you absorb the same thing without space. So all the viability purpose effects being now ethanol has been several technology layers. Classical mode of making ethanol is to have the sugar factory sugar from sugar cane. But then the benefit is almost less. You can government that you can just allow of trade. Then we can also convert the ballast. Second generation. Then we can convert all in agriculture, basically rice, wheat, all of them. So these technologies are available. And government of India has Pradhan Jeevan. So they have, for example, the part of this Jeevan, but as a part of promoting green policy, there are standards, right? Initially, basically, so many was written out about their game. That's the way. The similar to of being either easily. That is not very clear. So today, the development standard is 20%. And 20%, when it was just a technology level, was a becoming very now, I think, I don't know about 6 or 8 plants are the second. And it's about supply. But in terms of quantity of supply, even more, because getting better ethanol problem, and also our question of other places we can convert sugar to various or other like excessive food grades Over the long run, we will be for non-usage of unpredictable. We will consumption. But permanent benefits. And that has having significance of life of them. And so blending not too sure like the issue because substantially grown. So that will be plus one. The cost of it as well as quality is concerned is quite complicated. Convert food to economic even more. All these companies that are thinking convert other biomass to 280% into ethanol. That actually is not complicated. The government is giving out subsidy for both. But it is not reached that complicated. Now, this is not the case of things. But recently, Punjab was not being elevated. So Punjab was different. They said that I will use this stubble and convert it into compressed biomass. And if you see the cost of energy, these years, the compressed biomass is way cheaper than the energy company. Why I'm saying this is, again, somebody in a policy, it's a big artist, lying on it. It's a good policy, right? But it's really, what another policy is technology diagnostic. How to use PLS compressed biogas. We cannot run a class with biogas. If you like it, it's really cheap. So, I think that the environment policy is to not just the context of whatever but that's I always see a picture of it all and then
Very much to your density on the statements and not dynamic as well.
Yeah.
Yeah. As a lot of respect that I would like to honor our guests in the room. And correct the environment. To be honest, I think what's giant and good associated with that and my similar associated in the fact that and explaining I will also request Dr. Thomas also to join in the estimated. I think that it's all and six also in the see the voice.
Dr. Anil Kotkar, sir. Dr. Amit Srivastava, the delegates from the AICT, Registrar Evaluation, Joint Director, associate directors present here today, HODs, faculty, researchers, students, ladies and gentlemen, present both online and physically over here. A very good evening. That is already fun. Yeah, four. My proud privilege. I did so that. It's my proud privilege and MIT's proud privilege to host Dr. Anil Kakolkar here at MIT as part of this CICT Distinguished Chair Professor lecture on a very relevant topic. So relevance of nuclear energy produced or net zero, net zero CO2. As I showed that brought out, I think it's very true that only in the newspaper we had that topic capturing the headlines of 6 nuclear plants coming at Jetapur in Maharashtra, coastal Maharashtra. And this was in news years ago also, and there were a lot of protests. I don't know how much of it was from genuine safety concern and how much for political reasons. I also remember decades ago in one particular state, there was one political party which was in opposition and fought with the when we found out that the nuclear plant was coming into the state. And when the political party came in power, it went ahead fully supporting the installation of the nuclear commission. So, yes, let's keep coming back to the talk again. MIT Manipal takes a lot of pride in its 65 years of legacy of excellence in both academic delivery as well as research. It also says a lot of pride that we are a hub of experiential learning, and this experiential learning is delivered through our practice schools, through about 70 plus clubs, which are half of the technical, half cultural, and also 20 plus major projects where our students come together and they work on Formula Car, Solar Mobile, Mahasarovar Manipal, Team Manipal Racing, Rocketry, Satellite, and many more. Winning very important national and international competitions and making us proud. It also provides an opportunity to our students to get a lot of lifelong life skills, such as leadership, responsibility, integrity, discipline, more importantly, teamwork, stress management, and many more. The delivery of this kind of lecture here is also an endeavor at MIT to provide improved opportunities of interaction between eminent personalities like you, sir, with our students, with our researchers. What these interactions do is allow us to have an overall perspective of specific knowledge domain, but also improves our widens our knowledge horizon. And that's very, very important to all of us. And for this, I would like to express my sincere gratitude to the ICCT, Dr. Srivastava once again, and Dr. S.S. Bhatt and the whole team to make it happen. Thank you so much. Before I end my talk, I will see that we will have many more interactions like this in the weeks to come, sir. Each one of them is going to evidence very keen interest from all participants here. Thank you, Jerry.
Dignitaries of the line and online. First of all, I would like to thank Dr. Anil Kakolkar on behalf of MIT and MAHE for his excellent and informative and eye-opening talk on the issue of nuclear energy. And you are a very good teacher, sir, I can tell, because you have answered so many of our students' questions, which sometimes we feel irritating So you have answered them very calm way and very informatively. Thank you, sir. And we would like to have many more patients with you. Thank you. We also would like to thank Dr. Amit Srivastav and the AICT team for providing us such an opportunity under the scheme of AICT Distinguished Chair Professor. As Director told, we would like to have many more such distinguished chairs. We place our gratitude to all our MAHE administrators for their encouragement and support extended to us in all the events. Our sincere thanks to our director, Dr. Anil Rana, and the joint director, Dr. Somshekhar Bhatt, for always backing up in such type of events. A big salute and thanks to our Associate Director, Faculty Development, Dr. Shankaran Bhatt, and his team for their efforts in bringing the scheme to MIT and successfully organizing. We thank all the associate directors, assistant directors, head of the departments, and section heads for supporting the program. A special thanks to Registrar Evaluation, Dr. Vinod V. Thomas, for joining us on the occasion. And many researchers in the field who could not join us in the offline mode have joined us in online mode. This was possible because of the live streaming of the program in the AICT WebEx, and also it was available in YouTube. We thank and place on record the efforts of audiovisual and information system for the successful live streaming. We thank the faculty, students, and research scholars of various other institutions, as well as MAHE and MIT for joining us in this program. We also thank the security section of MIT for logistic arrangements. We are thankful to district administrators for giving us necessary instructions and support. We recognize and thank the members of media and press for giving a wide coverage of the program. We thank everybody who has helped us directly or indirectly. Thank you, one and all.
Thank you so much. Namaskar.
Thank you very much for participating in this event. All the university relationships that are Thank you very much.